Hi everyone, we are Team Alpha Detective Agency. Our project is about making a murder mystery game. Jerry and James are our programmer and game designer, and Jerry is also our co-producer. Kat and Tuesday are our narrative designer, who is our programmer, and I'm artist and producer. Our instructors are Chris and Jonathan. Then let's move on our game overview.
So our first section is project overview, or what our deliverable is. Our deliverable is a 6-player murder mystery party game, and it's about 90 to 120 minutes long. And also it's in cyberpunk setting, and it's web-based for PC and phones. So we developed this game in Unity engine with WebGL plugin to support the web-based gameplay, and we use Photon to support the multiplayer experience of our game. Just a quick recap of our experience. So we will first introduce the world to the player with videos about the scenario. Then player will be able to select their characters. And it then comes to our core game loop, which consists of several rounds of investigation, discussion phases. In each investigation phase, the player will search the clues on their phones individually and then talk about them in the discussion phase together. Finally, they will be able to accuse one of the fellow player as a murderer, and then we will provide them the ending video based on whether they accuse the correct murderer or not.
Awesome. So as a brief narrative overview, Ava, the daughter of a notorious CEO of a brain chip manufacturing company, has been found murdered. The company has recently been developing a technology called Memtech, which allows memories to be recorded and then explored. The scientists have been able to recreate Ava's memories into a digital memory map, and there are 6 player characters, and each player character was seen during Ava's last day. Therefore, they are suspects. These are our 6 player characters. Each of them have a distinct background story, connection to Ava, as well as a special ability.
Okay, so this is our core gameplay experience. So we start from introduction, where the players will select their characters and read their background stories. And then on the PC, you'll see each characters. And during this phase, each player has to introduce themselves to the other players to get into the role-playing aspect of our game. And then after after the investigation, after introduction, we enter the first investigation, which on the player's phone, you can see you click on the map and scan for interest point, and you'll get clues or puzzles from the interest points. And then on the PC, you'll see a map that shows how many interest points are left in a room. And then after every player has used up their action points, we'll enter the discussion phase, where players will have the puzzles and clues they got from the investigation phase, and then they'll be able to solve puzzles and also share clues. So sharing clues will put the clues onto the PC, which is on the detective board, so all the players can see it. And then they can try to piece the stories together. And then after all the clues are gone, or if the players feels confident enough to accuse who the murderer is, you can enter the accusation phase. So on the phone, each player will choose whoever they think is the murderer, and on the PC, you will see the result. Yep. So here's our...
During our game, at first, 6 players will scan the code to enter the game. After entering the game, it will be the introduction phase. An introduction of background story video will be shown on TV. It will show players who has been murdered, why they will be here, and who they are. After that, each player will enter the character selection phase to select their character. Each character has different skills, background, motivations of murdering, and one of the character is the real murderer. Players need to find out who is the real murderer by investigating and discussing in the next phases. Before entering next phase, there will be a tutorial video showed on TV to help player understand the core game loop. In the investigation phase, player will explore the map on their phone, clicking the screen to collect clues. Those clues will be stored in players' own phones. After players collect all the clues on the map, they will enter the discussion phase. There will be a detective board on TV to help players to organize clues and puzzles. Players need to decide if they want to share their clues to everyone on TV. Once clues and puzzles shared on TV, after the discussion of these clues and puzzles, players can drag the clue on TV to the position it related. When the time of discussion is out or players think there is nothing to discuss, they will enter the next round of investigation to collect the clues. Each investigation phase will enter a new map, and there are 6 maps in total. After players explored all the map and think they know who the murderer is, they can choose to enter the final accusation phase to vote the murderer. In the accusation phase, the one who has the most votes will be the final murderer, and then on the TV it will show players if he or she is the real murderer.
So for playtests, we did 7 on-site playtests and 4 virtual playtests. And then some of them were able to play to the end, and about 3 of them we are able to play to the end, and others, because of technical issues or time issues, we are not able to do that. So average, it took about 1.5 hours. And then here's our playtest. So what we did well is our core game loop, which is the discussion and investigation phase, worked pretty well. So the players were able to pick up on it after like the first round. And then our characters work well in terms of like the role-playing part. It helps the player get into the story and get into role-playing. And then our narrative structure, which is talking about the each map connects to a specific character, so it guides the players through the story a bit better. And then the design choice to encourage social interaction, which is talking about our detective board and sharing clues and also like transferring puzzles. So to progress in the story, you need to interact with each other. So what we improved after the playtest, we adjust the action point system. So some of the actions that used to cost action points now do not cost action points, so it makes the gameplay smoother. And then we added tutorial videos and tutorial slides to make the navigating through the UI a bit smoother and like more intuitive. And then we also did some narrative change, and we'll get into that later.
Thank you, James. Our second section is our retrospectives. What we could improve, what could be better, and we will also mention some of the problems we made that are still not solved. The first thing we can improve is the playtest arrangement. As mentioned, it's hard to arrange our playtest because it takes a long time, and also we need 6 players for each playtest. And also, we have preference for players. We want them to be familiar with the murder mystery genre, and it would be better if they are familiar with each other, since it's a murder mystery party game. And also, it's hard to playtest without the digital version, since we have some unique interactions between players and the detective board on the PC, and also some functions like transferring puzzles. What we did for our playtest arrangement is we playtest our tech and the narrative together after the digital version is available. And also, we want to playtest the whole experience for every playtest. However, what we think could be better is we playtest with only on-paper clues for the narrative first, and then moves to the digital version later. Also, it would be better if we have several mini playtests for each memory instead of having the playtest for the whole experience.
So one of the main narrative issues that we faced was the scope of our project. At halves, our plan was to progress through 5 scenes of Ava's last day, each with between 10 and 33 clues to discover. Because our original narrative outline that we created in week 4 was strong, and reducing complexity would make the mystery less satisfying to solve, we didn't end up reducing the scope. In fact, we expanded the number of clues in several of the scenes in response to playtesters who needed more clarity. And the most significant change to the narrative structure since halves is adding a new memory scene as a tutorial. Adding this new scene at the beginning helped the experience seem much more cohesive, since it allowed players to examine Ava's body and fulfill the expected part of the murder mystery genre that way. While we're satisfied with this choice, and we think that the complexity of our narrative was very strong, it did mean that when a playtest had technical difficulties, it had to be cut short due to the length of time that it takes to play through our game. Therefore, scenes at the end of the experience were playtested less often than those at the beginning. To mitigate this large scope, we used AI art tools such as Blue Willow and Midjourney to generate images for many of our clues. Aside from the scope of our clues, the other main narrative challenge was refining our character sheets. In playtesting, we found that our noir style of writing was effective in building immersion, but was an obstacle to our players' information retention. Our solution to this was to organize the character sheet differently. We presented a section about your secret in plain language with direct instructions about what to reveal and what to hide from the other characters. Some playtesters also felt that the character sheets were overly long. This is a convention from Jubensha, one of our inspirations, which is a Chinese genre of murder mystery game, and we wanted to keep this very complex background information and very long background information. So we created a visual hierarchy of fonts, colors, and sizes and bolding in order to make it more accessible and digestible for players. We also made it so that the players would be able to access their own character sheets throughout the entire experience, so they wouldn't have to remember everything.
But we also got some UI UX design problems during the investigation and discussion phases. Some player feels that it's not intuitive enough. For example, like the transportation between different maps, and also how to like interact with the maps to collect clues, and how to like make use of the detection board, or how to like share clues. And we also got so many tech problems. So the most challenging tech problem we have will be the disconnect issue. So it happens mostly on the iOS devices. When the iOS devices pause the browser or idle for a long time, the iOS devices will automatically pause the browser, and so that the server will be disconnected. And how we solve that? So our current solution for now is for when the disconnection problem happens, the user will have to refresh the browser to enter the game again, and then reselect and rejoin the room. And what we think is a better solution will be probably make use of the Photon API, the reconnect and rejoin API, so that the player can automatically rejoin and reconnect to the server.
So we already published our current version to the public, and in the future we want to continue to publish our future version to the public, and improve our UI, replace the map, and make the interaction more intuitive.
And also fix existing problems. Thank you, Lee. The last part is our player testimonials, or how we measure our success. We think we did a good job in offering the murder mystery party experience. So as you can see, some of the playtesters said he enjoyed the way the clue revealed themselves, like during discussion, investigation phases. And others think it's cool and fun being one of the characters in that kind of cyberpunk world. And also, somebody said like solving the puzzles is accomplished, and it's satisfying. Like they piece together all the clues at the end of the discussion. And we also have two comments from one of the playtests. The first comment is like the playtest is super excited when she solved the puzzle, and she expressed that kind of feelings to other playtesters. And for one of the murder players, he feels interesting to watch other players interact. And we also want to offer the special thanks for all our voice actors and playtesters. So we are Alpha Detective Agency, and we make murder mystery games, and it's a cyberpunk noir setting, and it's networked multiplayer game. Any questions?
You said you've released it to the public. Did you do it long enough ago that you know if anybody's picked it up? And have you reached out to groups like maybe the Game Creation Society to pick up your game and play it and test it out for you?
We haven't had that kind of plan, but it's like all public on our website. So if you are interested, you can just go to our website and you can enter our game site like by that website. Yeah.
Can you talk about what amount of effort was needed just to stand up the murder mystery game to a point where you could start innovating in that space, and what kind of innovations you were able to do on top of that?
Sorry, could you repeat the
Yeah.
question?
Yeah, I'm curious. It seemed like there was a large amount of work needed just to create a basic murder mystery game, just to get to a point where you could start thinking about, I don't know, digitizing it, or what kind of innovations were you able to add to that, and the breakdown of that work. I was trying to figure that out during your presentation.
Yeah, so that's a good question. As Mo said, there are a lot of different types of murder mystery games out there, and it does take a lot of effort to make a narrative that's complex enough to be satisfying. We played a Western murder mystery, like traditional party game. We played Jubensha, and we played quite a few murder-related board games. And we found that one thing that hadn't been done in this space was the big screen and little screen idea. And that was a very rich area that we could explore in for players hiding clues from other players or revealing clues to other players. So yeah, we found that in a lot of the games, it was very satisfying to put clues together visually on a detective board, and it was also very satisfying to hide things from other players. So that's the designs that we leaned into.
The reason why we do having a player has their own phone and also the PC is because each player has their own secret you have to hide from the other players. So the screen is to share clues that you think points to other people and also hides your personal secret. And then so that's the reason why we implement this kind of personal information and also public information.
Hi, this is Team Disco, and here's our final presentation. This is our team: Constanza, Alexa, Venia, Sarah, Muru, and Penghua. Our clients are the Center for Transformational Play and Jessica Hammer, who is also our instructor. First, problem statement. In project-based courses, like in peer feedback exchange process, people usually don't get trained to give high-quality feedback, nor to use feedback productively. They give critical feedback poorly and afraid of receiving emotion-provoking feedback. So we started from the research base of CDP. They had a lot of published papers about peer presence and the definition of high quality and low quality feedback. And they brought up a challenge to us: what is the thing that could improve feedback exchange process, and how could we handle that? Our client want us to explore the design space of peer feedback platform, which train students while they exchange feedback. The concept should be innovative, the prototyping should be various, and insights and documentation should be presented. Our delivery would be 2 prototypes and design test doc. The prototypes would be 1 interactive and 1 technical. Based on the scope and feasibility, we narrowed our scenario down to the feedback exchange process in project-based courses, and our target users are college students.
Yeah, so based on the presented scenario, we ideated 30 designs that could tackle the different areas of the current existing problems of peer feedback systems. And after narrowing them down, we chose a design that presents an innovative interactivity for practicing peer feedback exchange, and also a feasible scope that our robust team of 6 designers could work together on. And after testing the design, we got Feedle, which is a platform that trains students to exchange high-quality feedback while they're in project-based courses. And to help better understand how Feedle works, we have a demo video. So let's say in this project-based class, we have Penghua, who struggles to engage in peer feedback exchange because, number 1, she doesn't know how to give good constructive feedback, and number 2, she is afraid of being emotionally attacked. But with Feedle, she can now practice to overcome her worries. With the app, Penghua can view a list of feedback sent from her peers along with mixed sample feedback and practice digesting the content in a more helpful approach. The swiping interaction, viewing the explanations of sample feedback, and rating real feedback cards by their quality and helpfulness are Feedle's key interactions that teach what makes a good and bad feedback, and also recognize unhelpful feedback before being emotionally affected by them. Another key design within Feedle is on the send page. Penghua can see her peers' preferences on what type of feedback they'd like to receive, and at the bottom of the interface, there is a tips section that can help her write the feedback more in context to their preferences. And finally, there is My Vault page, where it stores the swiped real and sample feedback cards and their descriptions, a sent and received tab for viewing peer interactions, and an Analyze tab for seeing your performance on using Feedle, so that it motivates Penghua to keep practicing and sending high-quality feedback to her peers when they need it.
Right, so let's talk about how we designed Feedle. So we designed Feedle based on 3 principles. First, we designed a feature called interspersing feedback for helping students to better give feedback, for help students better review feedback. And we also designed a function that is sample feedback learning, so that students can recognize what is high quality feedback and what is low quality feedback. And finally, we also did a design principle that is feedback reflection, so you could use the feedback reflection you learned from sample feedback to give a better feedback. So first, what is interspersing feedback? In Feedle, students review feedback card 1 by 1, and you can only see the feedback content from the front side. Students will need to identify a feedback as either high quality or low quality, and swipe the card to the corresponding direction to review the feedback's backside. And after the review, student would learn that FIDO mixed sample feedback with real feedback. Unlike real feedback, sample feedback are telling student what a high quality and low quality feedback looks like for the reference. So why we designed interspersing feedback? We designed it based on 2 reasons. First, through identify the feedback quality, we want to emphasize the content and distance the emotion provoked by the feedback. And we also want to introduce an objective way to view the feedback by giving them examples to follow. When an emotion-provoking feedback turns out to be a sample, FIDO is able to provide a sense of relieving and a sense of affirmation. And also, by mixing sample into real feedback, we want to embed a learning experience in small bits, so it is effortlessly easy to follow. If a student knows what an unconstructive feedback looks like, it is easier for them to filter out similar real feedback and not get affected by it. So we tested interspersing feedback with 2 methods. First, we tested with a mixed feedback review in the real context of a CTP public talk. And we also did an A/B test with more than 30 participants on a functionable tech demo in the context of ETC projects. In the A/B test, we have 2 groups. We have A group to review the feedback interspersely, and we have the group B to view all the sample feedback first, and then view all the real feedback later. This is how we tested. So what we learned from the test was actually interesting. In terms of emotion, we find that A group actually has a better positive review to the feedback exchange activity, which infers that interspersing feedback may help with the engagement and also help students to focus on what they can learn from feedback. We also find that emotion-provoking feedback level is highly personalized and varies between individuals. This is slightly different from our hypothesis, but with this insight, we then designed a feature in FIDO's feedback giving page so that the recipient's personal preference can be visible to the feedback giver. So in terms of learning, we also designed a rubric that contains tags and description to generate sample feedbacks. We use both manually and AI to generate sample feedback. And it turns out it's really effective to mimic real feedback in both emotion and content. Sometimes the sample feedback even get recognized as real feedback more than real feedback themselves. However, to our surprise, in the A/B test, we found the group B, who learned sample feedback first, actually mentioned the tags more than the group A, which infers that group B, who learned sample feedback first, it could have been setting up a knowledge base of what's high quality and low quality feedback, and it's actually good for them to learn the trade of feedback. So this insight as a guidance for CTP's future work, it is possible for them to make a progressive interspersing procedure, which is mixing more sample in the front and then mixing more real later.
So what is sample feedback learning? We previously mentioned about we're doing the flipping card functionalities. So for the sample feedback card, we put sample feedback on the front side of the card, and when users see that, they can swipe left or right to determine its high quality or low quality, and after the card is flipping, they could see how this sample feedback is actually being categorized. So on the back side of the sample feedback card, users could see what this sample feedback is being considered as high or low quality, and also they can see the genre of this sample feedback belongs to. And we generated a genre based on research papers, and in this whole learning process, users could clearly learn how feedback should be like. And we get it tested during the playtest day, and around 27 participants attend the playtest day. So we develop a whole testing process. First, we let users to draw a bird in 2 minutes. And after that, we let all the user build sample feedback without letting them flip the card. So users would put the sample feedback in different genre they think is high or low quality. And after they finish viewing all the sample feedback, they're gonna start reviewing and flipping the card. And then they could see what's the tag on the back side of the card and learn how this feedback belongs to. And after that, we'll let users to redraw the birds in 2 minutes. And let's see what's the result. This is one of the results from our participants, and we could clearly see after flipping the card and learning how to draw a better bird, this participant come up with a more colorful birds with more feather. And based on this process, we can tell people can improve when they learn from high quality feedback, because the user categorized this feedback as high quality feedback in the learning process. And this is one of the results, part of the data visualization result from this playtest day. So after we let the user doing the whole drawing process, we let them fill out a survey, and they put how they feel in this learning process. And we could see almost 70% of the participants would consider this as a positive learning process, and the overall experience is considered as peaceful.
Okay, so this is our last principle, feedback reflection. We came out two hypotheses when we're discovering it. The first one, user could understand and utilize those feedback after reflection in my vote session. And then the user will give high quality feedback based on receiver's tag and tip rubric. We already introduced tag before, so what is tip? Tip are suggestions for further call to action sentences for specific tag for our feedback giving process. So about the tag and tip rubric, we categorize and associate tags in high quality, neutral, and low quality based on our research, and create tips for high quality and neutral. Low quality don't have tips. We don't want to encourage them to give low quality feedback. So why we designed the tag and tip rubric? We use tag to create connection from the start to finish in our Fido app. And we use tips only for the feedback giving process. It is kind of call to action design, guiding the user to leave feedback. So we have two tasks for the feedback reflection. The first one is for feedback giving. We have an A/B test, which ask participants first, watch an elevator page, then write a feedback straightly or based on text. Finally, they are asked to rewrite the feedback with tag and tip system to see is there any differences. And then we have another playtest in soft opening. The tag demo test with ETC project. Some learning of this project already been introduced. Besides that, we also have tests how the user assign tag to real feedback and how the tag cover users' needs for the feedback reflection. So through those tags, we found that with those tags, the participants could be better understand and utilize those feedback. And the tag and tip system could work as guidance and help them give better feedback. We're also glad that tag cover most of the user definition of the feedback quality. Those are two word cloud show the tag participants describe the high quality and low quality feedback in the user testing session.
So during the HAL presentation, a faculty pointed out that our swiping features might be too binary because it only allows left and right swipe. So we added a quality rating system after the user flipped the card, where the user can rate the quality of the feedback they received. However, we later discovered that because the rubric for the quality of the feedback are relevance, form, and the sentiment, so it caused that feedback can have a complex feeling. So a feedback can be valuable, but it also can be low quality. So we changed it into a helpfulness rating system. We differentiate the helpfulness and the quality. We did a lot of secondary research on CPT paper and used the real data and analysis to create a design. Then we ran a bunch of tests before we finally deliver the final product. To make sure that our design are human-centered. And by doing all of this, our designs are really grounded in the real data and the research and focus on what our users really wanted and needed. We also split into small groups to make sure everyone's idea can be heard and everyone's ideas contribute to the final idea. To make the scope manageable and to make the best use of our team's talents. We divide our 5 talented designers into different roles, and our programmers focus on the lo-fi prototype development for the dirty test. To summary, we work with CTP to create a prototype that used the interpersonal training, sample feedback, text, and tips to train students to give and receive high-quality feedback. Now we are open to questions. Thank you.
Thanks, team. So if I'm looking to use this in a classroom, what would you say the learning curve was starting out? If I want to teach this day one, get my students to use it, what am I looking at as far as training? And is there time to refine that? And how does that interact with the flow of my class?
Sorry, can you repeat the last part of it?
Yeah, just so how does integrating this into my class, how do you get, how complicated do you guys see that being on top of presenting the week one day one stuff off the class?
Yeah, so we did, for everyone else, so we did collaborate with Ricardo to test the feedback exchange process in the DAS class. Unfortunately, we don't retrieve too much responses, but we find some interesting pattern that people are actually more inclined, for example, students in your class are more inclined to give verbal response or verbal feedback to each other, but they are not super good at giving long and quality and constructive feedback, mostly because they are mostly interdisciplinary students and they have little knowledge to other domain. So this is something we find really challenging to solve as a feedback quality problem. So it's more like the natural of interdisciplinary project. So we later then focus on the feedback exchange process, which is one time, which is not long term. But I think the CTP would have a lot more work if they want to tackle with the long-term project, which is contains many students from different domains. Yeah, I don't know if that answers the question. Yeah.
Thank you. So I've been sitting here since you showed the example of the bird and the feedback that was given about the bird, and then the second revision of the bird. And what struck me was that context for the feedback, meaning what the creator is trying to accomplish, is really crucial to whether the feedback is useful or not. And I wanted to know how you dealt with the context of the task as a way to evaluate whether the feedback was useful or not.
So that's an interesting question. We have an aspect of because the useful or not useful is based on the user, based on the feedback receiver, not us to decide that, right? So we have a function that ask the user when they're receiving feedback and flick the card, they will have a score rating system to rate the feedback is useful or not. So that's kind of give them a sense if they rate 5-star, that is a really useful feedback. So that's kind of, we give the freedom to user to define it as useful or not.
But isn't, you're trying to teach people how to give useful feedback, not only just receive it, right? So a giver of feedback needs to understand what's useful. It isn't just always in the point of view of the receiver.
Yeah, that is very interesting. So there was actually 2 questions. First is how do we know that they are learning from the useful feedback that you mentioned? But the metric we're using here is actually the high quality and low quality metric. So basically, if a user think that feedback is high quality to them, they usually perform better to follow the instruction in the feedback. That's what we learned from the feedback from the playtesting. And for another question, you're asking how did we associate feedback giving and feedback accepting? So this is two dimensions that we are trying to tackle with. So first one is how do they receive feedback? So that's what we mentioned as if they think this feedback is high quality, they usually to intake the information more. So that's what we find. And for feedback giving, that's actually not tested in the bird drawing test, if that answers the question. So like we test the whole design in different segments. So we test the feedback reviewing and how they utilize feedback to improve their work in that bird drawing test. And later we test feedback giving in other play tests. For example, the soft opening A/B test, we test how they give feedback to each other. So, and then in that play test, we're just giving them the tags and tips that is embedded in the system for to let them know what's high quality feedback and see how they react to it. And the answer was like they follow the tips and tags pretty good. Does that answer the question?
Yeah, I don't agree.
All right, that's time.
All right, thank you guys.
So hello everyone, we're Team Bridging Time, and this is our final presentation. Our team consists of 6 people. We have Elisa, Steve, Jennifer, Yifan, and Ivy, and me, Chi-Wen. Our instructors are Mike and Scott, and our consultant is Mo. A quick overview of the Bridging Time AR app. It is a mobile AR app that is designed to have a unique and interactive experience that helps users to learn the history of the hot metal bridge. Our app will take the user back up to the era when the hot metal bridge was served as a crucial connector for the J&L steel mill. And we're going to provide them with a linear narrative experience which helps them to immerse themselves in the history. Through the app, we want to help the people who are whether from Pittsburgh or visiting here to learn more history about Pittsburgh and also the hot metal bridge. And also, we're going to give them some engaging and location-based experience. During our research and playtest, we found some pain points, and also we came up with some design opportunities. Firstly, the relatively long distance of walking, we see it as an opportunity to help us to help the user better immerse themselves in the history, and also to provide them with some a design to incorporate more information about the bridge. And secondly, the safety concern of staring at phone while they're walking we also take into account. To solve these problems, we add some background audio and guidance while they're walking, so people can pay more attention to their surroundings instead of staring at their phone all the times. And thirdly, the difficulty of envisioning the past of the bridge can also be addressed by using the AR to overlay some historical elements such as tugboat or the steel factory on the surroundings.
Okay, next I'm gonna talk about the user experience. So our main experience is a single-person on-site experience which takes about 15 to 20 minutes to finish. And we also have 2 minor experiences which are AR Selfie and Archive. For our main experience, after the user launches the app and opens the main experience, they will get to see an introductory video which takes them back to the year of 1945. Then they will follow a route to 3 designated points from the south side of the river to the pop-up on the bridge to view the past from their lens. For each destination, we provide a vintage-looking map for them to know where to go. The map is drawn according to the historical Pittsburgh map from the 1940s.
And if the map is not clear enough, we also provide reference images for this place. When the users are walking, they will listen to an audio narration about the history of Hot Metal Bridge and Pittsburgh in general. The length of the audio is carefully timed so that it's slightly shorter than the average walking time taken to walk to the spot. We hope that while the users are walking, they can put down their phones, which minimizes safety issues. But if they do want to stop and read, we also provide captions. Once they arrive at the spot, they can align the view in their phone with the yellow contour we provided. This serves as a fun way to make sure that both the direction and the location they're at is correct. And after confirming, an old animated photo with our models made will appear to show the path of this specific site. And at the end of the experience, they will get to see a wrap-up video which talks about today and the future of Pittsburgh. The AR selfie function can be accessed at the beginning of the app or at the end of the main experience. Here, the users can choose to take pictures with all the models which appeared in the previous experience. This serves as a playful way for them to leave memories with the space. And the users can also check the archive for all the images, videos, and models which appeared in previous experience. This is also a substitute for people who cannot go on site or want to revisit the experience at home. And we can give credit to all the sources here.
I'll talk about the artistic and narrative content of the experience. As Ivy outlined, we've broken it up into a series of listen and learn portions and interactive video portions. I'm going to go into each of these in more depth. Our narrator is a character from the year of 1945. They start by talking about why the iron and eventually steel industry were located in Pittsburgh in the first place, namely the transportation access that the Three Rivers offered, as well as the coal deposits within the hills of Pittsburgh itself. We also touch on the foundation of the Jones & Loughlin Steel Company at this particular site. The guest is then brought to the first part of the interactive experience. We created a 3D model of one of the steamer barges that used to paddle down the river and composited it into a still photograph where we also added smoke and water effects to add depth and life to the picture. The guest then begins walking to the first part, second spot, and listens to the listen and learn portion. We've timed it so that they have just a little extra time to walk in case they're unfamiliar with the area. They're not distracted while they're looking for the next spot. On this leg of the listen and learn, we talk about how the hot metal bridge was originally built in 1898 to literally transport molten iron from the ELISA furnaces on the north side of the river to the open hearth furnaces on the south side. This enabled such enormous gains in productivity that during World War II, the J&L produced 15% of the, the J&L produced 15% of the entire steel output of the United States and was the most protected bridge in the country. We also talk about some of the difficult working conditions in the factories. It was difficult to find data specifically on the J&L, but for comparison, at the Carnegie factories down the river, workers had about a 1 in 3 chance of getting a permanent physical disability by the age of 50, and a 1 in 7 chance of dying by the same age. Then when they reach the foot of the bridge, we present them with another photograph, this time of a train going down the bridge. Just like the other photo, the train itself and the effects and the shadows were all composited in by us. Then the guest continues walking towards the center of the bridge. Here we discuss the macroeconomic and environmental reasons that the steel mill eventually closed. After discussing the effects of industrial pollution, we show a photograph depicting one of the factories in operation, where we added the smog blocking out the sky and the smoke emanating from the factory, as well as the water effects again. And finally, we wrap up by discussing the long-term legacy of the steel industry that extends into the present day, and make a case that steel is just one stop among many in Pittsburgh's long history of reinvention.
Now we'll talk about challenges and issues we faced during the process and how we improved through applying changes. As we were developing our project, we gradually found that integrating large AR objects was really challenging. Despite using very strong filters and effects, we still found the AR objects didn't blend seamlessly to their surroundings. We also encountered issues when it came to the real-time GPS system. We found that the object was placed into wrong position very often. So one of the comments that we received a lot of time during those days was they look like toy, which was very frustrating to all of us. To solve the problems, we came up with innovative solutions. Instead of solely relying on the real-time GPS system to indicate where the object was, we decided to let the users manually indicate where they would like the object to show up by lining up the object to the correct place. Besides, we also reached out to our faculty consultant, Mo, and received his valuable suggestion of giving up the idea of blending large AR objects in the real world. Instead, we generated animated old-time photos to create a more authentic and immersive experience of bridging time. We also encountered challenges when it came to implementing on-site testing on the bridge, including the long distance between here to the bridge and also the unfavorable weather conditions. So we decorated our room by printing out large posters to create real-life scenarios for playtesters, and we also conducted regular playtests in our own project rooms to make sure that playtesters love our project. And we also recognize that there are huge differences between conducting playtests in a more controlled environment and conducting playtests on the bridge on site. So we also conducted enough multiple times of playtests on the bridge to make sure that everything was functioning well. So for next part, I will hand it off to Alyssa.
Thank you, Yifan. So now I will talk about the technologies we use for the project. We leverage Unity as our platform, as well as AR Foundation and AR Core for our functions, and the app is built for and run on Android phones. Now it's time for our final deliverable video. After the introduction, the video will take the users back to year 1945.
The year is 1945.
And then our map will get the users to the first spot. By aligning the outlines, we can see an old photo taken at this spot about Hall Metal Bridge merging into the real environment, as well as the taco that we modeled, rendered, and animated.
The engines were specially designed to haul heavy loads throughout the factory site, and the torpedo cars carried the molten iron. They are torpedo-shaped so the barrel could be turned.
The audio can be paused anytime.
In order to pour out the hot metal without leaving any excess inside.
Here at the second spot, we will see a torpedo car carrying the molten iron, and this is showing how the steel transportation used to look like. The third spot shows the site on the south side of the river that used to be steel furnaces.
In spite of whatever economic hardship we may face, Pittsburgh will always manage to reinvent itself in every new era.
After the tour, users can take selfies with their favorite model, which can be moved, scaled, and rotated to add more fun. The photos will be saved to their phone album with our team's watermark. And in the archive, we can appreciate all the images, models, and videos, and read more about the histories behind them. Since our demo video is recorded in portrait view, we sincerely invite you to have a better experience by trying it out in our project room this afternoon. Also, to gain insights into how people interact with our app and to better improve it, we invited about 20 playtesters. grateful for the time and dedication of all our playtesters. Their involvement has been instrumental in shaping our final product, and we hope our experience was enjoyable for all of them.
Okay, so for our final deliverable, it is an app, an Android app, and our project website, and also design documentation and technical documentation. So in the future, the pattern of this app can be easily used to create similar experience for other tourist destinations. And besides, our user can easily share their selfie on popular social media and to generate interest and excitement about this app and also this tourist spot. To enhance these possibilities, we could introduce more selfie effects in the future, including those that are using image recognition technology. And also there's possibility that we can partner with the Rivers of Steel organization to promote the app and help with historic preservation in Pittsburgh. So this is the end of our presentation. Now we're open for questions.
Hey, I noticed you used some sound in the piece, but you didn't talk much about that. I'd like to hear a bit about the sound design. Like, you're looking at all these historic things. How do you try to confirm whether it sounds anything like the actual machines would have? And then for the voice acting, maybe, how important would it be for a published app to try to recreate an authentic Pittsburgher voice or something like that?
Thank you for your question. We realized that the on-site experience is, if we want to make it very immersive, the sound is really important because you are not in that time. So we did a lot of background research and watch different videos about related areas and make sure that the sound is historical correctly. And for example, the train, we added the very different layers of the sound. I'm not a sound designer, but it's just out of intuition. I have no idea. Yeah, so that.
As far as the voice acting, we sort of did the best we could. We toyed with the idea of going for a more, a character that was more strongly set in the place in the history. But just given that didn't reflect any of our experiences, we weren't totally comfortable taking it all the way in that direction. We also found that from talking to our playtesters and users, that people were just sort of more interested in the general trivia and historical knowledge that the piece offered than the other aspects of the experience.
So I liked your playtest video, but I also, want to get a better sense of how people interact with the app in practice in ways that you might not have expected, or what did they do with it that was part of their play, and less part of how you designed it.
So one part that we found that's really interesting during our playtest is that for younger generation, they kind of prefer to use the selfie function a lot and have the willing to maybe share this picture with their friend after our playtesting is done. But for people who have maybe older, they prefer to learn more history about the bridge instead of using the extra feature of it.
Yeah, and I also want to mention the difficulty of on-site playtesting is both challenges and chances for us, because we also conducted many playtestings in our project room in a controlled environment, and we recognize the difference between being indoor and on-site, and we kind of iterated those changes based on both environment of playtesting. For example, in the room, we have already printed out the correct spot for our 3 tours, and the users will not worry about walking to the correct spot. And also, the distance between each spot is relatively short in our room, and this makes the playtesters kind of confused because our audio is really long, about 4 minutes. But that is the correct time for them to walk to the second spot when they are on site. So I think this also helped us better improve our experience.
How did you incorporate the 3D animated models in the photographs and made sure that they looked seamless?
That was partly a matter of doing some color correction to make sure that the models that we had already initially been creating to be part of an AR experience would fit into the composite. And otherwise, it was a lot of trying to make sure that things, both in the 3D camera, then in the composite, were lining up correctly, and it seemed like everything was in the correct position. So we would check to make sure that things were actually sort of true to life in their scale and their distance. For instance, like the train, like in the 3D render, is coming from approximately the same amount of distance that is halfway across the bridge when it's coming towards you. So it's still, the scale feels correct.
Hello, we are Team Level Up.
I'm James. I'm Snow. I'm Ela.
And I'm Timmy Polly. And our faculty members on our team are Dave as our instructor and Heather as our instructor and client. And I want to thank our external experts, being the backbone of our project. They helped us a lot scoping and defining what Level Up really is. So let's now dive into the project. Level Up is a level design toolkit, which will be used as the core toolkit for Intro to Level Design, which is a new ETC elective course taught by Heather Kelly starting fall 2023. And it's important to know that Level Up is not a game experience, and it's not a standalone educational tool. And it doesn't necessarily contain everything level designers ever needs or wants. And its purpose is not to develop a game to publish, rather than for students to practice level design skill and make a portfolio piece. Let's look at the overview of our client needs. So our client wants us to make a toolkit that's mimicking AAA industry standard tools for level design, which contains character and a related mechanic, as well as our assets. And this toolkit should be able to create a third-person, non-combat, environment-based traversal game level. And the features we have in the toolkit should be surrounded in learning fundamental level design skills. And our users shouldn't need any programming or art skills to use our toolkit. And let's expand a little bit more on that. With that understanding, our core user will be future ETC students who are possibly Unreal Engine beginners and are also aspiring game designers. And to make these features better fit into an educational purpose, we had a curriculum meeting with Heather throughout the semester. And some of the key topics the course will cover, including white boxing, introduce and ramping player abilities, level navigation, environmental storytelling, create a variation and combination on theme or mechanic, and so on. With that, our deliverable became pretty clear, which is an Unreal Engine 5 plugin that has a player character and animation needed, with a selection of interactive objects, blueprints, templates, art assets, as well as installation and use documentation.
Okay, so let me introduce the unique value of our toolkit. So why aren't users just download an existing level design toolkit, but use our toolkits? So we have two main reasons. The first reason is that the existing level design toolkit, they are all designed for the experienced Unreal users. But for students who would take our course, they may have no Unreal experience at all. So our toolkit can not only help them to build the level, but also can help them to learn Unreal Engine because we provide them detailed documentations. And the second reason is that our toolkits are designed specifically for the non-combat traversal game. So we carefully choose the different assets that are relevant to this type of game and put them into our put into our toolkit, so that they can use our toolkit to make this type of game, and it's very suited for the curriculum of level design course. So let's look at the toolkit itself. So we made this toolkit as a plugin, so it's easy to install to your computer, just like other Unreal plugins. And also, we designed this toolkit user interface, so the users can easily to find assets inside of our toolkit through this user interface. So by developing this user interface, we solve a navigation problem. If you see on the left-hand side, it's the Unreal default content directory. So you really can't tell where is the important content in those folders. But with our own designed user interface, we have fully control to let users to see what the important folders are. And next, let's our team members to introduce what's actually inside of our toolkit.
So first, we want to produce the industry standard characters. So for the UE default character, it only has the jumping and move and working function, which is insufficient for our traversal games. So in order to give it more mobility, we bring in the pose to give them the environmental traversal extra mobility for the game designer to design the level. And for the per character animations, we not only do the springs and sliding animation, which is the typical industry standard tool springs, and we also with our poles, we have this pole bounce and hand jump features that's related to the pole and add extra mobility for the designer. And the level designer can use this to customize their own traversal systems. And also we talk about the module that you can actually use when you're doing the level design. So first we're talking about the pacing modules that help you to bring the pacings. So the first one will be the level logic systems that allow you to drag and drop the checkpoints and also the response points into the level and just use it directly. So this helps you to break down the level into sections. And also we're thinking about like adding the excitement into the pacing, because the non-combat system might lack of the excitement without the combat systems. So we add a health system and a timer system into it to bring you the excitement level.
So we have realized the importance of the event system in the level design, especially for interactive levels. So we have pre-made two types of event triggers for the designers. The self-evoke one supports like the general event calls, like grabbing a pole and opening a door, basically satisfy all the basic needs for level design beginners. The remote calling one, on the other hand, is an advanced feature that can let the character trigger an event remotely. Like when the character pushes a button, the pillar will be destroyed. With those features, the students will be able to learn how different types of triggers affect players' experience. Navigation guidance is another core element in the level design. Excuse me. And it helps students to learn like environmental storytelling and linear experience design. Our pre-made guiding assets actively help the character move from one place to another place in the game, while some of them also require the character to include ramped mobility. Like those hangers, the character needs to get the pole first to use them. Our navigation guidance also give students, level design beginners, a spark of ideas for building sequence and doing creative design in wayfinding. For instance, the designers can create a hole on the ground and force or imply the character to use the pole and the hanger to jump to go over it.
Okay, let's talk about art assets. So creating a space using navigating mechanic and visually leading art assets is very common in level design. So in addition to functional guidance, we also include some visual guidance assets. These assets will provide user to create a linear gameplay sequence visually. And here's our library of art assets, also contains some construction meshes, such as bridge, stairs, variety of platforms, and boxes. Those assets are probably scaled to our player character, and which will allow user to create a block out a level layout quickly. And to further mimic the art assets in a AAA level design kit, we include other decoration assets, such as the landmark in the toolkit. And these assets are easily accessible for user to create an environment that holds the story of our player character. And a theme art assets kit is never to limit a level designer creative, working with kits of art and creative of the reuse the assets a level design need. And our art assets library was built to create a variation of combination of a theme and a mechanic. Okay, let's remember to talk about our documentation.
So with the amount of assets we mentioned above, we came up with this use documentation, which includes from how to download our toolkit to how to use our assets. And the documentation can help the students to learn our toolkit more easily and avoid being overwhelmed by our toolkit. And also we have this catalog, which can help the users to jump to the page they need very quickly. And some of our users may have no experience of using Unreal 5, so we added some basic operations, tutorial links, and hotkeys of Unreal 5 in our documentation. And also we have highlight some functions in the hotkey page. So by providing those additional documentations, we hope to encourage the users to form a good level design habit within Unreal 5. And besides of the use documentation, we also made a series of video tutorials, and each tutorial specifically described one function within our toolkit. And we hope to use this way to minimize the students' time to doing some research and help them to learn and practicing their level design skill. Oh, sorry. Yeah, and this is the video about how we use our toolkit. So in the video, my goal is to make the player go to the endpoint. So I add a pole at first, and if the player have a pole, he can do the wall jump and jump further. But I want to make the level more interesting, so I add a hanger from the toolkit, and then I add a damage zone into the level, which if the player go into this area, they will get hurt. And then we add a lava, which to indicate the player that this is a dangerous area. So after the player have a pole, he can hang on the hanger and swing to the other side. And when the player drop off the platform, he will get hurt. So now the level is more interesting than just the jump to the end. So our toolkit can inspire the students and help them to create a more interesting level.
And we made all that happen, and I hope you have a better understanding of what the toolkit contains and how to use them. And how do we test it? We hosted a level design game jam. We invited Eric from Ubisoft to be our roundtable expert to give feedback during the interim. And we invited Jessica from Shell Game, and of course Heather, our instructor, to be the judges of this game jam. And this game jam lasted one day. We had 14 participants. Each participant has 6 hours of work time. To better test out our deliverables, we give them a limit of using the functions and assets we provided only. And within the 6 hours, they were still able to complete the whole iterating process with the designer from Roundtable. And finally, we have 7 final submissions. Now, let's look at some of the final submissions. The first level right here, which is also the winning level of our game jam, was designed by Lachlan. Lachlan used all the mechanics very smartly and laid out a very clean design. And this is an excellent example of what white boxing in level design should be. And here we see him creating interesting wayfinding using the mechanics we provided. And next up, we have another level that's very mechanic heavy. This level was designed by Steve. Steve was able to use the visual guidance assets we provided to really stretch out the mechanic challenge. And this one is a different approach from another Unreal Engine beginner, Derek. He approached this design problem with a narrative approach to it. And right here we see a lot of good use and reuse of landmark assets. And here we see a reuse of a door button, one of our puzzle piece, as a elevator button to create interesting wayfinding in a traversal level. And last but not least is a design by Kai. Kai is an experienced Unreal Engine user, as you can see, with a limited time for a user who doesn't need the onboarding process. He was able to pump out a good amount of content on a very complex map. And with this testing, with this big play test, we were able to improve our documentation and our assets management. And with that, we're pretty confident that we provide a good starting point of assets library and also a good onboarding process with user documentation and additional support we provided. And that's all of our presentation. We're now open for questions. Thank you.
Yeah, just one quick question. How robust is this with regard to Unreal updating? Unreal likes to update a lot, so this looks really good. And I love, I think you have some great things, but when Unreal updates in a month, where are we?
Okay, so we design all the function assets in our toolkit using Blueprint. So it's really easy to update with the Unreal version, but without breaking something else. So I think it's robustic. Yeah.
Yeah, I have a similar question. Given that we're at the end of the semester, and this is kind of a handoff to your client, Heather, what is the biggest risk right now for what you're delivering?
I think the risk would be when something breaks or there's a new bug found. Right now, we're able to find most of them and eliminate all these bugs, but I think we're hoping for being in contact with Heather and to prevent breaking from happening. But other risk.
And along those lines, with Heather as your client, do you have a clear delineation as to what assets are yours and what assets are coming from third parties and what the rights are to redistribute those?
So we have a spreadsheet about the external access we place on our toolkits, and you can look into the spreadsheet to know which part is made of ourselves and which part is we adapted from the third party.
this is a kind of unusual project for ETC, making a tool that's going to be used in future classes. How does it compare to working on another kind of project? Were there places where you felt frustrated because it wasn't a more traditional project, and how did you kind of overcome those things?
Yeah, I think the hardest part is that we're getting the update about the course requirements because Heather is also developed her course in the same time. So we are like updating our toolkit to meet the newest requirement of the course. And also we have like to address this issue, we also contact some level designer from the industry, and also we send out surveys to the industry people to know what their needs is and how we can like make this course better together. So yeah, I think that's the frustration part about the not clear requirements, but we're like keeping updating it and making it better. Yeah.
All right, thank you.
We are Team Illuminati from Dynamic Luminescence. My name is Sai, I'm the producer for the project.
I'm Stephanie, and I'm the artist.
I'm Jiajian, programmer.
I'm Chloe, also the programmer.
I'm Chloe, the artist.
And this is our collaborators / advisors. We have Mikkel and Marcus in our collaborating team. They're all here. So hi, Marcus and Mikkel. We have Heather and Mo as our faculty advisors. And this is our project overview. So we are building a tool that projects visual effects onto 4 dancers' body. And together we want to kind of reflect traditional African cosmology. And before we continue, let's show you a trailer of the dance.
So this is Mikkel Luna, our collaborator. He's a Nigerian-American multimedia artist, filmmaker, and also an engineer. He erases the boundary between art and technology by weaving through African mythology into his work. So this is one of his previous art practice. He would directly paint on the model's body and capture the light through the specially built camera filter. And from this, he is opening a new chapter of his artistic practice with our project team through interactive performance art.
So our project is based on the 4 different world ages originated from African Igbo cosmology. The first one, Ugaga, represents the unity and oneness. The second stage, Ugachi, represents the separation and awareness. The third stage, Uganwu, represents the light, sun, and civilization. And the last stage, Ugazi, represents the backwardness and sufferness. So this is our collaborator Mikhail's vision and mission about this project. So basically we're using the tech and art as a base to combine with the choreography and the music to create a responsive performance and ultimately bring the African Igbo cosmology to life, which is our final outcome. So to achieve our vision and mission, we have broken down our tasks and assignments into two parts, the technology and art.
So before getting into our tech details, I will shortly talk about our deliverables. So our system will have a user-friendly control panel that control all the sequences, and also 4 sets of dynamic visuals of the performance. We will also provide all our codes and plugins of the system together with a user menu. So how does our system work? We break it down into 3 parts. So the first part is Azure Kinect. We use its depth camera as a sensor, and we grab all the data into Touch Designer, our software, and generate the full visuals accordingly. And then we use the projector to project the visuals back to the dancer's body. While we developed the system, we encountered a lot of problems. As our system is designed for live performance, we need to track the dancer's fast movement. So a latency like this will really not work. And accuracy is another problem. So this is the first prototype we developed with Azure Kinect's built-in body segmentation algorithm. You can see the results really poor here. Someone is even not detected. So how we solve this problem? So on the projector side, we use a gaming projector, which has a lower latency. And on the software side, we optimize the way we generate the visuals. And on the Azure Kinect side, we use our own customized body segmentation algorithm. So how would this algorithm work? We under the truth that our stage will always be kind of clear. So we pre-record the stage depth information and subtract it from the raw depth image we get from Azure Kinect. And then what left here is all the things that does not belong to the pre-recorded stage, which is the dancer's body. Cool. So with all the methods above, we solved these 2 problems, and we reduced the latency from over 200 milliseconds to less than 40. But that's still not enough. So currently, we get the clear body mask, but this body mask is observed by the Azure Kinect. And the projector has a different location. So if we directly project this mask back to the dancers, mismatching would happen. So how we solve this problem? Actually, projector performs pretty much like camera. So instead of taking in lights, it's shooting out lights, right? So if we consider the projector as a camera, then the problem becomes we have an image from a camera here. What's the correct view of the camera there? So first, we 3D reconstruct all the dancer's body information in the virtual world. And then we use computer vision algorithm and also knowledge of camera calibration to calculate the projection matrix of the projector. A projection matrix is a camera tool that used to project 3D points into 2D pixels. So with all the information above, we now can know the correct view of the projector and thus have a really matched visuals.
So next, I will introduce our visuals in depth. So we have created 4 sets of visuals according to the 4 world ages, and each stage has 1 to 2 visual treatments. So the first one, Ugaga, the unity and oneness for the visual one, we added some forces, extra forces and turbulence to create the particle's own movements. And we also used the metal ball to simulate the people's movements so that the particles in the background can actually move when the dancers are moving. And for the second one, the Udu pattern, so the Udu pattern is the fortune-telling method in traditional African culture. So we use the sorted circle consisted with particles to create this tunnel effect, and then we use the text to transfer it into the texture, and then we added the noise chop to randomize the textures. So as you can see, the 16 different patterns are changing from time to time. And the second one, Ugachi, is the age of awareness, separation, and death. So we converted the people's position in the 3-dimensional space. We used this data to convert it into an RGB map, and then we used the GLSL particle system to make the particles trace the people's outline to create this dotted outline and the hollowness effect.
So this is the third stage, Uganwu. It's the stage of sun, civilization, and war. Therefore, for the first set of visual, we use spreading of squares that adds up to a pyramid symbol. So the spreading of the squares were done through the noise chop and also a limit node to create the outline. And for the second visual, we created these bouncy lines not only mapped onto the performer's body, but also to a still object such as props, which also caught us by surprise. This is the last age, Ugazi, which is the age of suffering and backwardness. So for the first visual, we created a meatball that interacts with the dot grid that creates these tangled lines. And for the second visual, it's non-interactive visual. We used force point and turbulence on top of noise chop, and we randomized the effect to create this wavy, snowy effect at the end.
Last week, we had an interview with our collaborators, Mikhail and Marcus, and the full version is on our website. Here's a clip of them talking about our project's cultural significance.
I think the contemporary Black dance space, there's a lot of work with static projection, but all of the work that we saw online we didn't even see a single piece where a Black dancer was even present for a spatial augmented reality performance. I mean, there was no Black dancers, not even talking about Black choreographers, Black storytelling, or African myths that were incorporated. There was not even a single Black person in the entire space. And so it shows that this project is breaking completely new ground, not only in terms of the fusion of African myth into spatial augmented reality and live performance. That's never been done before. The fact that you all were able to build a platform that can also register darker skin tones also shows the level of work that you all did and how the platform is something that is, again, thinking in ways that I think many other people in the technology space are just really not thinking about it. And then the fusion of all of these pieces together, it's really groundbreaking. And as Marcus mentioned, I think that when people see the work, their jaws are going to drop because this type of thinking and fusion within Black artistic spaces, because I think that's one of the other parts that has been so important for us, is to think about how do we make sure that Black artists are not left out of and excluded from the use of these technologies. How do we make sure that Black storytelling, African storytelling is really incorporated at the forefront of these innovations as well? And this project, this semester, has provided a platform and an opportunity for that I know that all of us are amazed by, impressed by. The dancers were blown away, and so it's really breaking new ground, I think, for in this space.
Next, I'll go through more details of our deliverable package with which the project can go further. The first is system with controller. We'll deliver a well-built functional system with an easy-to-navigate controller. It supports customizing compositions and orders of the visuals and will provide a set of tools for installing the work in various sites. For visual treatments, we have 4 sets of visuals with 10 in total. They are individually unique visuals from static to responsive and corresponds with 4 different stages. The user menu includes hardware, software, walkthrough, a list of fragmented devices and price, and how to choose projector based on performing space. It also has an installation guide that covers things like calibration and alignment. Additionally, we'll provide services like remote support and help installing the work in Artist Studio.
So what went well in terms of our project? So first, we were able to deliver a dynamic control system, which was also part of our final deliverable. And secondly, modular and improv choreography on the day of filming worked really great on site with our visuals. Thank you to our choreographer, Marquita. Thirdly,
our communication was key to our project, I think. Transparency and honesty was one of our core values. We tried to keep everything honest and transparent with our both collaborators and the faculty advisors. And lastly, innovative, creative solutions that not only we worked around the technical difficulties, but also conquered the challenges. But what would we might do a little differently if we had more time allotted? First, in terms of software selection, we might look into other node-based software such as Isadora. Touch Designer isn't super stable in terms of performance, and also since it's node-based, it's not super flexible on site. Secondly, integrating music and beat into choreography, such as having interactive music as well as the interactive visuals. And where would our work travel next? So on the Mikhail's team's end, they will be going to North Carolina Museum of Art in North Carolina, and also Martha's Vineyard Performing Arts Center in Massachusetts. And this is only the beginning of where our work will take place, and more will come. So throughout the semester, we experimented a lot with our fellow student dancer, Yushi Lee. Huge thanks to her. So for the remaining of the 1 week, we will test more with other genres of the dance or music and explore other uses of the system under different narratives. Huge thank you.
So just a little summary before, we have a really great team here. And we were working with incredible collaborators, Mikhail and Marcus, and also the dance team with Marquita. We also have very supportive faculty members who help us along the way. And together we have built this well-built system with a culturally significant value. And a special thanks for everyone who helped us along the way, just even a little bit. But we're ready for questions and answers.
I'm curious you could speak a little more to the collaboration, particularly in the choreography. You mentioned really briefly that the idea of props kind of surprised you. I'm curious, are there things that the collaborators pushed into the tech, and if there's things the tech pushed into like the performance?
So in terms of props, it caught us by surprise because by using depth camera, not only it will map onto performers since it's in front of the Azure Connect, but also since it's in front of it, it will also capture onto the still life objects such as props. That was caught by surprise because we just discovered that like through like happy accident. We were like, oh look, it captures onto this as well, and we did like variety of testing, like how about this fabric, how about this paint, et cetera, et cetera. So that was exploration on that end. And sorry, what was the first part?
I guess the collaboration, especially around like the choreography.
Oh yeah, so in terms of choreography, we had like so we always have weekly meetings with our collaborators, and as the filming date approached and throughout the whole semester, we came in close contact with Marquita and the performers team, and they came prepared with the set choreography, but also a modular and improv choreography. So I think it would be like 8-to-2 ratio, 8 being like the set choreography and 2 being the improv. So when they arrived on site of the filming day, since they are out of state, they are from Georgia, yeah, so they were able to mix and match the choreography accordingly to the sound, but also the visuals through some adjusting and flexibility, et cetera. So that came in very, yeah, flexible.
So again, yeah, just the background. We tried to bring the dancers in, but due to budgeting and timing reasons, they cannot participate, like just arrive at Pittsburgh before the show or before the filming day. So we communicate quite a lot on the space itself, the technical difficulties, and also like every aspect of what we might foresee. So we were able to like kind of just communicate those points out, and then they can prepare themselves modularly in terms of choreography so that they can improvise quite a lot during the day, and then ended up resulting in a pretty dynamic way.
Yeah, it seemed like you had a lot of technical challenges to overcome in order to get this platform to work. How did you balance kind of where to try to overcome the technical challenges and where to try to lean into them as ways to kind of inspire different modes of interacting?
So by that, are you asking how do we kind of balance like where to stop on tech development and then where to like kind of pick up through like visuals? Cool. Thank you for that question. So yeah, we had like pretty hard lines or like kind of milestone for like let's say week 5, week 7 or something. We stopped like anything over the technical development. So like kind of optimizing everything to that point, and then we develop visuals along like the boundaries that we are seeing at that point. And then maybe like some interesting things like exploration-wise or creative solution, like some new technical challenge come up, and then we just try to like minimize the timing of that development. So like, let's say half a week or a week, let's try to solve it. If we can't solve it, let's just like not do that or find out there's another visual way to like kind of treat that. Thank you. Thank you.
Thank you.
Congratulations to the team who wins today. Good job.